This presentation discusses Search R1, a method to improve how language models use search engines. Current models struggle with tasks needing current info or complex reasoning. 1. Existing solutions aren't ideal. Search R1 uses reinforcement learning, so the model learns how to search effectively as part of its reasoning process, showing better results on Q&A tests. Figure 1 illustrates the training setup. Both PPO, top, and GRPO, bottom methods are adapted. The core idea is the rollout module, where the LLM generates text, can call the search engine, gets results, and continues generating. PPO uses a value model to help guide learning, while GRPO compares multiple generated answers to determine the best direction. The search engine acts like an external information source within this learning loop. Section 3 details how Search R1 works. It sets up a learning goal where the model learns to get high rewards by answering correctly using search. A key trick is loss masking. The model only learns from the text it generates, not the search results themselves, preventing instability. It uses standard RL algorithms, PPO, GRPO. The model interacts iteratively. Think, search, if needed, get info, think again, then answer. Rewards are simple. Did it get the right final answer? Algorithm 1 details the step-by-step response generation. It starts empty. The model generates text token by token. If it writes a query between search tags, the system pauses generation, runs the search, and inserts the results between information tags. This cycle repeats. It stops if it runs out of allowed searches or if it produces a final answer wrapped in answer tags. Section 4 presents the experimental validation. Search R1 was tested on 7 diverse Q&A datasets. It was compared against various existing methods, including models that don't retrieve, standard retrieval methods, RAG, and models fine-tuned with or without RL. Using standard LLMs and Wikipedia data, Search R1 showed significant improvements, getting more answers exactly right, even on datasets it wasn't trained on. It works well for different model types. Figure 2 looks at the learning process using PPO versus GRPO. The graphs show how quickly the reward, correctness, improves during training. GRPO, orange lines often, tends to improve faster at the start. However, PPO, blue lines, seems more consistently stable, less prone to sudden drops, particularly with certain model types. In the end, both methods learn effectively, although test results in Table 3 suggest GRPO might have a slight edge in final answer quality in most cases tested. To wrap up, this paper presented Search R1, teaching LLMs to use search effectively via reinforcement learning. Unlike prior methods, it learns how and when to search during its reasoning process without needing pre-labeled search examples. Experiments showed this significantly boosts performance on knowledge-intensive Q&A. The analysis also offered useful insights for training such models. Future research could make search strategies even smarter or apply this to images and text together.